when we usually look at the history of AI, we're talking about people who are obsessed with the mind.
Right.
We're talking about philosophers, trying to map out logic on a chalkboard, or
Mm-hmm.
cognitive scientists writing down these strict rules of thought.
The whole software of the soul approach.
Yeah.
Trying to find the ghost in the machine before you've even built the machine.
Right. But today, we're unpacking the work of someone who didn't really care about the philosophy. He didn't care about abstract definitions. He just wanted to build the thing.
He was a builder.
We're talking about Yann LeCun. And what's so fascinating is that while he is, literally one of the three godfathers of AI,
Turing Award winner. Yeah.
the guy who effectively gave computers the ability to see, he is currently the loudest voice in the room telling us that the AI we are all using right now is a dead end.
It is a massive contradiction, isn't it? You have the man whose research powers everything from, self-driving cars to the Face ID on your iPhone.
Everything.
And he's looking at tools like ChatGPT and basically saying, this isn't it. This is a distraction.
He actually uses the word doomed, right?
He does. He calls the current path doomed.
That is a heavy word coming from a godfather.
It is.
So that's our mission for this deep dive. We're going to trace LeCun's journey from the Parisian suburbs to the labs at Facebook to understand why he thinks that. We have to get inside this constructivist worldview to see why he thinks the future of AI isn't language models at all, but something he calls world models.
And to really get it, to understand why he's so skeptical of the chatbots, we have to go back to the beginning. Because his philosophy, it hasn't actually changed all that much since he was a kid.
Okay, so let's rewind. 1960, north of Paris. Yann LeCun is born. And looking at the research, this whole constructivist mindset, this idea that you have to build it to understand it, seems like it was there from day one.
Oh, absolutely. It was in the groundwater of that house. His father was a mechanical engineer. So the LeCun household was defined by what his biographers call a technical impulse. If you wanted to know how radio worked, you didn't go read a textbook. You took the back off the radio and looked at the circuits. You learned by doing.
And even his name has that history, doesn't it? I saw a note about his Breton roots.
It does. LeCun comes from the old Breton Lecouf, and Yann is just the Breton for John. So he has these deep, grounded roots in a very, practical, hands-on culture.
Okay.
But the story that really explains his AI philosophy, the one that explains why he's so skeptical about how we build AI today, it doesn't start with computers. It starts with model airplanes.
This was the aha moment.
It really was. As a kid, he was obsessed with flying contraptions. He's building these planes, dealing with lift, drag, propulsion. And he looks at the history of aviation and he realizes something crucial.
What's that?
He notices that the early pioneers who failed, the ones who crashed and burned, were the ones obsessed with feathers.
They were trying to build mechanical birds.
Exactly. They looked at nature, saw birds flapping, and said, okay, flight equals flapping. They built these ornithopters with flapping wings, that's biomimicry, and it fails because you're copying the form, not the function.
But the Wright brothers, they didn't fly.
No. They ignored the feathers. They focused on the principal aerodynamics, fixed wings, lift, drag. They realized that a plane needs to be inspired by a bird, but it shouldn't try to be a bird.
And LeCun applies this directly to the brain.
That is his core thesis. He calls it the bird analogy. He believes AI should be inspired by the brain, the same way a plane is inspired by a bird. But we shouldn't get lost trying to copy the biological messiness of a neuron.
I see.
We don't need to replicate the chemical soup or the exact firing patterns. We just need to find the aerodynamics of intelligence.
That's a really helpful distinction. It separates the engineering from the biology.
It does.
You don't need to build a synthetic brain. You need to build a machine that thinks. So fast forward a bit. He takes this mindset into high school where he's building synthesizers from scratch.
Which is really relevant because what is a synthesizer? It's a machine that takes simple waveforms like a beep, a sine wave, and by layering them and modulating them, it creates these incredibly complex sounds.
So complex output from simple layered input.
Exactly. It's a direct precursor to how he approaches vision later. You take simple edges, you layer them, and you make a face.
So he heads to engineering school, specifically EZ Paris, not a pure computer science program. I feel like that distinction matters. He's treating neural networks as circuits, as physical systems, not just logic.
He sees them as physical processes. And this path leads him, in 1988, to the holy grail of research, AT&T Bell Labs.
The research utopia. I mean, looking at the roster there, Nobel Prize winners walking down the hall, Unix being invented in the next room. Sounds like the place to be.
It was the absolute peak of corporate research. But for LeCun, it wasn't all harmony. He walked right into a massive intellectual turf war. And this conflict, it really defines the history of AI in the 90s.
This is the famous NEETs versus the Scruffies.
Correct. And you have to understand, this wasn't just a polite disagreement. This is a battle for resources, for respect.
Okay.
In one corner, you had LeCun and the neural network guys. They were the Scruffies.
Scruffies because their models were messy.
Messy is a good word for it. They were inspired by biology. They were hard to interpret. And this is the kicker. They were really hard to prove mathematically. You couldn't write a clean proof on a chalkboard for why a neural net worked. It just did.
And the other corner.
The NEETs. These were the statisticians. They were led by Vladimir Vapnik, who was actually just down the hall from LeCun.
Oh, wow.
Vapnik had invented something called the support vector machine.
Which, for those of us who aren't statisticians, is what exactly?
Think of it as perfect math. It's a way of classifying data separating cats from dogs using these very elegant, solvable equations. It's clean, it's beautiful, you can prove it works before you even run the code.
So Vapnik would look at LeCun's work and just see chaos.
He'd say, this is garbage, it's a black box, you're just getting lucky.
So you have the NEETs with their elegant proofs, and LeCun with his messy brain code, and the pressure is on him to prove that his scruffy approach can actually do something useful.
And that pressure cooker is where he invents the Convolutional Neural Network, or the CNN.
Okay, we have to pause here, because CNNs are arguably the most important invention in computer vision history. If you unlock your phone with your face, you were using a CNN.
Absolutely.
But to get why it was such a breakthrough, we need to understand how computers tried to see before LeCun.
They did it badly. The old approach was called fully connected. So imagine you have a digital photo. It's just a grid of pixels.
Right.
The old networks tried to connect every single pixel to every single neuron in the system.
That sounds crowded and really inefficient.
It's incredibly wasteful. But worse, it ignores the structure of the world.
What do you mean?
In a fully connected network, a pixel in the top left corner has no special relationship to the pixel right next to it. It treats the image like a random bag of sand. But in the real world, pixels next to each other form edges and shapes.
Right, an eye is usually next to a nose. The location matters.
Precisely. So LeCun went back to biology. He looked at the work of Hubel and Wiesel on the cat's visual cortex. They found that the brain doesn't process the whole image at once. It scans using local receptive fields.
It looks at little patches, like a spotlight moving across a dark room.
Exactly like that. So LeCun built that into the code. That was his first innovation. Local receptive fields. The network only looks at a small square of pixels at a time. Then he added weight sharing.
Okay, break that down. That sounds technical.
It's actually pretty simple. Imagine you have a filter, a little piece of code, that learns to recognize a vertical line.
Okay.
In the old systems, you'd have to learn vertical line in the top corner, then learn vertical line in the bottom corner all over again. LeCun said, no, a line is a line wherever it is. So he built a system where once the network learns a feature, it can find it anywhere in the image.
That must have saved a massive amount of computing power.
Huge. We're talking orders of magnitude. And then the final piece, subsampling or pooling. This is where you deliberately blur the image a little bit as you go.
Why would you want to make it blurry? You usually want things sharper.
Because you want the computer to understand the concept, not the exact position. If I write the number 3, it's still a 3, whether I write it slightly to the left or slightly to the right. Pooling lets the AI say, okay, there's a loop here, without obsessing over the exact pixel coordinate. It makes the system robust.
So he builds this Linnet 5 system. And this wasn't just some lab experiment. I was actually surprised to read that this was running inside NCR check readers.
It was essentially running the banking system. By the late 90s, something like 10 to 20% of all checks in the United States were being read by LeCun's convolutional neural networks.
Wow.
If you deposited a check in 1998, a neural net probably read it.
That is the definition of success. He built it, and it worked in the real world. So why on earth does the story then go into what everyone calls the AI winter? Why did people stop listening to him if his code was literally counting the money?
Because the academic world didn't care about check readers, they cared about math. The NEETs won the PR war. Support vector machines were mathematically provable. You could guarantee they'd find the best solution. Neural nets were still these finicky, hard-to-train beasts. Computers were slow, data was scarce, and the community just decided, This is a dead end.
So LeCun is basically exiled. He goes from being the hotshot at Bell Labs to what?
He, Geoffrey Hinton, and Yoshua Bengio, the three godfathers, became outcasts. LeCun talks about how they couldn't even get papers published. If you had neural network in the title, the reviewers would just roll their eyes and reject it.
It was toxic.
It really was. So they formed a kind of conspiracy.
A conspiracy.
Effectively. They made a pact to keep the research alive. They eventually got funding from the Canadian government, the NCIP program, which became this sort of safe harbor for the scruffies. They would meet, share ideas, and keep the flame burning.
So in those wilderness years, he had to pivot.
He did. He couldn't just do neural nets. And this leads to a really instructive failure, a thing called DVU.
I remember DGV files. I thought it was just some weird alternative to PDF that I could never open. I had no idea that was LeCun.
It was. In 1996, the internet was on dial-up. Sending high-quality images of documents was a nightmare. So LeCun and his team invented a compression method that separated the text from the background texture.
Right.
He could crush a document down to a tiny size while keeping the text perfectly sharp.
Better than JPEG.
5 to 10 times better. Technically, it was superior. But here's the lesson that burned LeCun. AT&T and the company they licensed it to, LizardTech, got greedy. They tried to keep it as a proprietary walled garden format.
Okay.
They wanted to charge for the readers. They wanted to own the standard.
Meanwhile, Adobe releases PDF.
And Adobe makes the reader free and the spec open. So PDF won the world because it was open. DJView died because it was closed.
And he learned from that.
He took that failure personally. He realized that if you want a technology to become a platform, the foundation everyone builds on, you cannot hoard it. You have to give it away.
That experience seems to directly inform what happened in 2013. The deep learning revolution is finally kicked off.
Computers are finally fast enough.
And Mark Zuckerberg calls.
The famous dinner. Zuckerberg wants LeCun to build Facebook's AI lab. And LeCun is in a position of power now. He says yes, but on one non-negotiable condition: open research.
Which for a company like Facebook or Google or Apple was unheard of. You don't give away your trade secrets. That's your competitive advantage.
Oh yeah, Google and Apple were locking everything down. They were treating algorithms like the recipe for Coca-Cola.
Right.
LeCun told Zuckerberg, if you want the best scientists in the world, you have to let them publish. You have to let them talk. And Zuckerberg, to his credit, agreed. And that is why FAIR Facebook AI research became such a powerhouse.
And the biggest weapon to come out of FAIR was PyTorch.
Right, and PyTorch is the perfect example of LeCun's engineering philosophy winning over the NEETs at Google. Google had TensorFlow.
Which was the standard for a while. Everyone used it.
They did. But TensorFlow was static. You had to define the entire computational graph, the whole flowchart, before you could run a single line of code. It was like drawing a blueprint for a whole bridge before you lay a single brick.
Rigid.
Efficient, but rigid. And PyTorch. It used eater execution. It ran line by line, just like standard Python. If you wanted to change the neural net halfway through the process, you could. It was built for the tinkerer. It was built for the scruffies.
And the research community loved it.
They adopted it en masse. It became the language of AI research.
So, LeCun has vindicated the neural net. He's won the Turing Award. He's at the top of the mountain. And now, here we are in the present day, and he's throwing rocks at the new shiny object. Large language models.
This is where we get to the core of his current worldview, and it is controversial.
He uses this cake analogy.
He loves a good food metaphor. The cake analogy is about how much information an AI gets while it's learning. He breaks it down into 3 parts: the cherry, the icing, and the cake.
Okay, walk me through the cake. What's the cherry?
The cherry is reinforcement learning. That's where you train an AI by giving it a score: good dog, bad dog. You play a million games of chess, and at the end, you get a +1 for winning or a -1 for losing.
Okay.
LeCun argues this is a tiny amount of information. It's just the cherry on top. You can't learn the complexities of the world just from a yes-no signal.
And the icing.
The icing is supervised learning. That's where humans label the data. This is a cat, this is a tumor, this is a stop sign. It's dense information, but it's expensive.
You need humans to do the work.
Right, it's limited by what we can label.
So what is the cake? The substance?
The cake is self-supervised learning. This is what LeCun calls the dark matter of intelligence. Think about a human baby. A baby learns gravity not because mom says equation 1.1 states objects fall, and not because they fall down a million times. They learn by just observing. They see things fall. They watch the world. The data itself is the teacher.
So his argument is that true intelligence requires the cake mass observation of the world and not just the icing of language.
Exactly. He believes LLMs are trying to build intelligence purely out of icing. They read text, which is a human compression of reality, but they don't observe reality itself. And this leads to his specific technical critique of ChatGPT. He calls them autoregressive models.
Autoregressive, that sounds complicated, but it just means predicting the next word, right?
Correct. It means looking at the sequence so far and guessing what comes next. But here's the math problem that LeCun points out. If you are just predicting the next word based on probability, you are constantly rolling the dice. Let's say the model has a 1% chance of making a weird logic error on any given token.
1% seems low. That sounds like 99% accuracy.
It is low for one word. But if you generate an answer that is 100 tokens long, those errors compound. It's simple probability. The chance of the whole sequence being correct drops exponentially. He calls this drift. The model drifts away from reality because it has no anchor.
It has no ground truth.
Right. An LLM knows that the word mouse often follows the word sofa, but it doesn't know that if a mouse runs behind a sofa, the mouse still physically exists. It lacks object permanence, it lacks physics, it lacks the common sense of a house cat.
Wow.
A cat knows the world is stable. An LLM thinks the world is just a statistical probability.
That's a brutal takedown. You can't reach human intelligence if you don't understand that things exist when you aren't looking at them. So if LLMs are a dead end, what is he building? He's not the type to just complain without an engineering solution.
No, he is betting everything on what he calls world models. And the architecture he's proposed is called JPA Joint Embedding Predictive Architecture.
Okay, GP. How is that different from a generative model like GPT?
The key word is embedding. See, the problem with trying to predict the future video style like generating the next frame of a movie is that the world is chaotic. If I show you a video, a tree in the wind, and ask you to predict the next frame pixel by pixel, you can't.
Because every leaf is moving randomly. It's just noise.
Exactly. Generative models try to predict the pixels, which is impossible. GP doesn't try to predict the pixels. It takes the video, it encodes it into a mathematical representation and embedding that strips away the noise. It ignores the fluttering leaves and focuses on the concept. The tree is swaying left.
So it predicts the meaning of the future state, not the picture of it.
Spot on. It predicts in embedding space. LeCun believes that if an AI can accurately predict the abstract state of the world, it can plan. It can say, if I do X, the world will change to state Y. That allows for reasoning and planning, which is what LLMs struggle with. They just improvise JPA plans.
It feels like the constructivist returning to his roots.
It really does.
He's trying to engineer an understanding of cause and effect. Now, we have to touch on the safety debate, because his old friends, Hinton and Bengio, are very publicly worried that AI might wipe out humanity. They're calling for pauses, for regulation. LeCun thinks that is, what's the word, preposterous.
He finds it ridiculous. And again, he uses engineering analogies to explain why. He thinks the doom scenario is based on bad logic. First, he uses the asteroid analogy. He says, worrying about AI taking over today is like mobilizing NASA to stop an asteroid that hasn't even been discovered yet.
Right, it's a hypothetical.
It's panic about a science fiction scenario. And the second one is the turbojet.
I love this one.
Yes. He says, look, early jet engines were dangerous. They exploded. People died. But we didn't ban them. We didn't stop aviation. We treated safety as an engineering constraint. You build better brakes, better sensors, better fuel lines.
He's saying safety isn't a philosophical problem, it's a debugging problem.
Exactly. And he addresses the will to power argument. People think AI will want to dominate us. LeCun says the desire for dominance is a biological trait. We evolved it to survive and reproduce. AI doesn't need to eat. It doesn't need to reproduce. It just needs to optimize an objective function. If we don't program dominance into it, it won't have it.
It's a very pragmatic view. It cuts through a lot of the sci-fi fear. So wrapping up the man himself, he's at Meta, but he's also advising QTI in Paris now, pushing for European sovereignty in AI.
Yeah, he wants to make sure the future isn't just owned by the American West Coast. He's very patriotic in that sense. He wants Europe and France to have a seat at the table. And personally, he's still a maker. In his spare time, he's 3D printing parts, hacking hardware. He's married to Isabelle Guillen, who is a brilliant AI scientist herself, so I imagine the dinner table conversation is pretty intense.
I can only imagine. Pass the salt, and what do you think about the loss function on that new model? It's funny, looking back at his career, there is this consistent thread. He's always playing the long game.
That's the takeaway. When everyone said neural nets were trash, he stuck with them for 20 years until they worked. When everyone said keep your code secret, he opened it up and changed the industry. And now when everyone is saying language models are the answer, he's saying, no, look deeper.
It really forces you to question the current hype cycle. We are also amazed that the chatbot can write a poem or pass the bar exam. But if the godfather of AI is right, we're just impressed by the icing.
And we're completely ignoring the cake.
That is the question we'll leave you with. Are we building ladders to the moon with these chatbots when we should be building rockets? Thanks for joining us on this deep dive into Yann LeCun. We'll see you on the next one.